Another type of rotary pump that moves liquid by trapping it in spaces and forcing it out of the pump is a lobe pump. Lobe pumps use lobes instead of gears to move processed liquids. The pump shown here is often called a two-lobe pump because each rotor has two lobes. But lobe pumps can have as many as 3 or 4 lobes on each rotor, depending on their design. The lobes are made so that they rotate closely together. This forms a seal between them that prevents leakage of liquid back to the suction. During operation, the lobes rotate and draw in processed liquid through the suction of the pump. As the lobes unmesh, gaps are formed. Liquid is drawn into these gaps and is then trapped in the spaces between the lobes and the casing. As the lobes continue to rotate, the liquid is moved along to the discharge of the pump, where it's forced out of the pump and into the discharge piping. Now is a good time to stop and check your understanding of gear pumps and lobe pumps. Based on what we've covered, where would you say the suction side of this gear pump is located? Vane pumps operate a lot like other types of rotary pumps. They trap processed liquid in spaces and force it out of the pump. There are 2 common types of vane pumps: sliding vane pumps and flexible vane pumps. This is an illustration of a sliding vane pump. This is the pump's rotor. It contains the vanes which can slide in and out of the rotor. As the vanes pass the pump's suction, centrifugal force causes them to slide outward. When this happens, the vanes trap liquid in spaces along the casing. The centrifugal force keeps the vanes extended against the casing, so the trapped process liquid is moved toward the discharge of the pump. At the discharge, the gap between the rotor and the casing becomes very narrow. This directs the process liquid out of the pump and forces the vanes back into the rotor. The reason the gap between the rotor and the casing narrows is because the rotor is offset. It's positioned away from the center of the casing, so that the gap between the rotor and the casing is very narrow where the vanes rotate back to the suction of the pump. In addition to directing most of the liquid out of the pump, this narrowing allows only a small amount of liquid to return to the suction of the pump. Another type of vane pump is called a flexible vane pump. Like other types of rotary pumps, flexible vane pumps trap process liquid in spaces and move it through the pump. In this illustration of a flexible vane pump, we can see all of the basic parts. Inside the casing is the rotor, and attached to the rotor are the flexible vanes. As with the sliding vane pump, the rotor in the flexible vane pump is offset from the center of the cavity that it's in. When the pump operates, process liquid is drawn in from the suction of the pump and trapped between the moving vanes and the casing. The liquid-filled spaces are moved along until they reach the discharge of the pump. At the discharge, the rotor is closer to the casing, so the pumping area is narrower. As a result, the vanes flex by bending over into the spaces containing the process liquid. This makes the spaces smaller and forces the liquid out of the pump. The big advantage of using a flexible vane pump is that the vanes form a tight seal with the casing. This characteristic is often used in pumps that are required to draw a vacuum on a process. In some pumping applications, it's critical to keep the process liquid away from the pump's moving parts. One type of rotary pump that can be used in these applications is a tubing pump. In a tubing pump, the process liquid is contained inside a flexible tube that's part of the pump. The pump's rotor works with the tubing to force the liquid through the pump. We can get a better idea of how this type of pump works by using this illustration. On this pump, the casing is in the shape of a U. Inside, the tubing follows the casing's U shape. Also inside the casing is a series of rollers mounted on a rotor. The rotor is attached to the pump's driver. During operation, liquid is drawn into the tubing at the suction of the pump. The rollers turn with the rotor and compress the tubing, trapping liquid inside. As the rotor continues to turn, the rollers force the trapped liquid through the tubing and out the pump's discharge. Tubing pumps normally don't have as high a flow rate as other types of rotary pumps, but they still have many uses. For example, they're often used as sampling pumps for corrosive or toxic liquids. Since the liquid is inside the tubing, It doesn't come in contact with the pump's components. In this topic, we looked at several types of rotary positive displacement pumps: screw pumps, gear pumps, lobe pumps, vane pumps, and tubing pumps. We saw some of the major components that make up each of these pumps, and we examined how the pumps operate.